This is a work through of the solutions to the June 2007 OCR Additional Maths question paper. Question 1, to solve the inequality, the first thing to do is multiply out the bracket. So we get 3 times x is 3x plus 6 is greater than 2 minus x. Collect x's to the left by adding x to both sides. So 4x plus 6 is greater than 2. Collect the number terms to the right hand side by subtracting 6 from both sides. 4x greater than negative 4. Divide by this 4. It's okay to divide by a positive number within inequality. So dividing by 4 gives us that x is greater than negative 1, which is the solution. Question 2. For a particle moving in a straight line with velocity given by this function or formula, to find the distance travelled between these times, we need a distance formula which is given as s is the integral from a lower limit of 1 to an upper limit of 3 of the function of v with respect to dt. If that function v is integrated, then we get 6t plus t cubed, which has to be calculated between the limits of 3 and 1. So substituting in, we get the first bracket evaluated with 3. That will give us 18 plus 27. Subtract the function evaluated using 1, which gives us 6 plus 1, which is 45, minus 7, which is 38 meters, which is the solution to that question. Question 3, a circle has the equation given, find the coordinates of the centre and the radius. So we need to apply completing the square twice to the left hand side to separate out the x and y things. So looking at the x term here, minus 4x, if we halve that coefficient, then we put negative 2 in the bracket, which is then squared, and we subtract from that 2 squared, which is 4. Then we've got to deal with the y, which is there. So we look at the y term, negative 6, so half of negative 6, negative 3, square that bracket, subtract from that the value of 3 squared, which is 9, and then bring down the 3 from the end. So that's the equation of the circle by applying completing the square. If we now collect like terms, which are the numbers, and take them over to the right hand side, then we get x minus 2 all squared plus y minus 3 all squared equals 10. So the centre is given by the negative versions of these number terms, which will be 2, 3, and the radius is the square root of 10. There were no units given, so we'll leave the answer without units. It is okay to leave the answer as root 10. For question 4, find all the values of x in that range that satisfy this function. If we begin by rearranging, so we do sin x over cos x divided through by cos x equals negative 4, then the left hand side is the identity for tangent of x. So we get a solution of x from doing the inverse tangent or arctangent of negative 4. So if we bring up the calculator to do that, we want the arctangent of negative 4, which is minus 75.96. Because of the value of this, I think it's acceptable to round this off to 0 decimal places. I'm going to put the answer as minus 76. So x equals negative 76 degrees. That's not in the range that's asked for, so what I need to do is have a little sketch graph that I can work out from there what the possible values are. So if I have a y-axis and an x-axis, I'll just extend this a little bit over here so I can get the negative 76 on. So tangent has the long sweeping S shapes that are typical of the function. This takes us up to 360 here. We've got a solution back at negative 76, which is down here. So if we take that across, excuse the quality of that diagram, then we've got 180 here, so we'll be 76 to the left of that. So we'll have a solution for x of 180 minus 76, which is 104 degrees, and we've got another solution that's 76 degrees to the left of 360. So x is 360 minus those 76 degrees is 284 degrees. So those are the two solutions for the function in that range. Question 5, for this car travelling along the motorway, brakes are applied, car decelerates, calculate the constant deceleration. So for part 1, we start by labelling the bits of information we have. We're told that it's initially travelling at 30 meters per second. So the value of u is 30 meters per second. Let's bring that back. The distance covered is 300 meters. The final velocity is 10 meters per second after that change during the journey. So if we look at the values given, we want A, the deceleration. So u, s, v and a are connected by v squared equals u squared plus 2as. V is 10, u is sorry, I'll do 10 squared, which is 100. U is 30, so 30 squared is 900. And then 2 times s is 600 times a. Subtract 900 from both sides. Negative 800 equals 600 times a. Divide through by 600, we'll get negative 4 over 3 meters per second squared for the acceleration, which is what we expect. It said it was deceleration and we've got a negative value. For part 2, we want the time taken to travel from A to B. So in that case we can use V equals U plus AT, because we have values for V, U and A now, and we're calculating T. So if we substitute in, 10 equals 30 minus 4/3 of T. Subtract 30 from both sides, we get negative 20 equals negative 4/3 of T. So obviously the negatives cancel. If we multiply it by 3, we get 60. Divide through by 4 is 15. So T equals 15 seconds, and that's that solution done. For question 6, finding the equation of the tangent to the curve. To get the tangent to begin with, we'll want the gradient of it, so we'll differentiate the y function. So dy by dx is 3x squared minus 3. We want that gradient at the point where x is 2, so if we substitute in for x as 2, then we'll get 3 times 2 squared minus 3. 2 squared is 4, times 3 is 12, take away 3 is a gradient of 9 at that value. The general equation of a straight line is y equals mx plus c. We know at the point where the gradient's 9, x is 2 and y is 6, so if we substitute in y is 6, gradient is 9, for an x value of 2, we can calculate that c is going to be 6 take away 18, c is negative 12. The question asks for the equation of the tangent, so we need to make sure that we put all that together to complete our answer. So y equals 9x minus 12. Question 7, use calculus to find the x coordinate of the minimum point. So we need to differentiate to find the stationary points of this function. So we'll get 3x squared minus 4x minus 15 by differentiation. Put that equal to 0 to find the stationary points. We now need to factorise that, which will go into 2 brackets because it's quadratic, and the brackets will be 3x plus 5 and x minus 3, which gives us stationary points. If we put 3x plus 5 equal to 0, then we get a stationary point at negative 5 over 3 and x equals 3. So at this point we want to test the gradient function to the left and right of this value, to the left and right of this one, to show which one is the minimum. As an alternative, we could look for the second derivative of the gradient of the original function. So we'll differentiate this, it saves a bit of time. If we do d2y by dx squared, then we'll get 6x minus 4. So when x is negative 5 over 3, d2y by dx squared will end up being negative. Don't need the actual value. Now negative means the gradient around that stationary point is constantly decreasing. In that case, that means it's a maximum. If we now do evaluate that with x is 3, so when x is 3, d2y by dx squared will be 6 times 3 is 18 minus 4 is 14. That's a positive result. So that means the gradient is constantly increasing, and that can only happen at a point that is a minimum. So we've shown that x equals 3 is the minimum, and we've got evidence that we know it is the minimum. Question 8. We've got 2 graphs using algebraic method to find the x coordinates where the curves intersect. So for part 1, that means we need to put 4x minus x squared equal to x squared minus 4x plus 6. They're the 2 functions. If I collect terms to the right, so I'll add x squared to both sides, subtract that 4x, so we'd get 0 equals 2x squared minus 8x plus 6. All of those are multiples of 2, so just to make things easy, I'll divide through by 2 at this stage. X squared minus 4x plus 3. That needs to be factorised. It's a quadratic, so it goes into 2 brackets, which are x minus 1, x minus 3. So x equals 1, x equals 3 are the answers to part 1. We were only asked for the x values for those. For part 2, it asks for the area enclosed by the 2 curves. So just need a bit more paper, so I've got some lines to write on. Right, so for part 2, we need to integrate between 1 and 3 the function 4x minus x squared with respect to x. That'll give me the area under that function. Then I need to take away from that the area under the other function, x squared minus 4x plus 6, and I'm doing that with respect to x. I knew to put this function first because it's a negative x squared. Negative x squareds are upside down U shapes, and I can see that the area under here, if I draw down from here to here, will be a bigger area than under this curve, which is the standard x squared shape. So I need to make sure I've got the 4x minus x squared first, otherwise I'll end up with a negative later on in the solution. So we begin by doing the integration, so we swap to square brackets. This becomes 2x squared minus x cubed over 3, and that's going to be evaluated from 1 to 3. Subtract from that the integral of the other function, which is x cubed over 3 minus 2x squared plus 6x, and that's being evaluated from 1 to 3. So just bring that back down, and I'll start doing that. I use a curly bracket while I evaluate all of this. So the first thing will be, if I substitute in 3, I'll get 18 subtract 9. Then I subtract this evaluated as 1, which would be 2 minus a third. Close that bracket. So that's all of this first part evaluated. Then I subtract. I'm now going to evaluate this thing. So I evaluate it using the value of 3 first, which gives me 9 minus 18 plus 18. Subtract this evaluated using 1, which is a third, minus 2 plus 6. Doing a bit of tidying up with the fractions, making them over a common denominator. I get 27 over 3 minus 5 over 3. That's having simplified each of these. And then for the second bracket, if I work out each of the square brackets, that becomes 27 over 3 minus 13 over 3, which comes down to 22 over 3 minus 14 over 3, which is 8 over 3 square units, and that's the solution to that question. Question 9, we've got 3 points. We can sketch those if we want, but I'm going to do it just arithmetically. Show that AC equals AB. So to do that, let's just scroll that back down for part 1. AC is given by applying Pythagoras to the points A and C, So I'll get 8 subtract -1 squared plus 3 minus 1 squared, and all of that is square rooted. So that gives me 9 squared plus 2 squared, square rooted, which is root 85. For AB, similar approach, using the 0.65, subtract -1 squared plus 8 minus 1 squared, and that's square rooted. That gives me 6 squared plus 7 squared, again square rooted, which is also root 85. So we've shown that AC equals AB. For part 2, write down the coordinates of M, which is the midpoint of BC. It says write down, but there's still a little bit of calculation to do here. So for M, we need to average the values of B and C. So it's 5 plus 8 over 2, comma 8 plus 3 over 2. So that gives us the coordinates of M as 13 over 2, comma 11 over 2. For part 3, show that lines BC and AM are perpendicular. So that hinges on showing that the product of the gradients is equal to -1. So I need the gradient of BC, which I'll do first. The gradient of BC is the difference in the y values over difference in the x values, which is a gradient of 5/3. The gradient of AM is the difference in the y values, which is 11 over 2 minus 1, over difference in the x values, 13 over 2 minus -1. That simplifies to 9 over 2 over 15 over 2. The 2's can be cancelled at this point, which gives me 9/15, which is 3/5. Just realised, just going back here, 3 minus 8 is negative, so it's -5 over 3. So the last step is to show that if I do the gradient of BC times the gradient of AM, that's equal to -1. Therefore BC and AM are perpendicular. Question 10. By drawing suitable graphs, indicate the region for where the inequalities hold. So the first thing I need to do is give myself some values to work with. So if we number these off as 1 and 2, then for function 1, when x is 0, y equals 4, and when y equals 0, x will equal 6. For function 2, when x is 0, y equals 8, and when y equals 0, x will equal 4. Which allows me to draw a set of axes. I need to go up to 8 on the y-axis, and I need 6 on the x-axis. So I'll just bring this up. y-axis there, x-axis there. So that's 6, 4, 2, 0. That's the x-axis. And then on the y-axis, we're going from 8 down to 0. Plotting the functions, we can use solid lines because the functions all have equals on them. So the first function 1 goes from 0,4 to 6,0. So that's that function. The second one goes from 0,8 to 4,0. The other two functions are defined by the x and y axes. It asks us to then shade in the region not required, so that will mean just this little bit in here is what is required. So we'll shade out what's not required. Notice I'm going to the left of the y-axis to indicate that we have to be greater than 0 for x and likewise below the x-axis. So I've shaded all around that and I've made sure I've only bounded the bit that's wanted. So we've shaded the region. For part 2, find a maximum value for x plus 3y subject to those conditions. So subject to these conditions, the key points are going to be here, here and here. So I need to use those and put them into that function and check. So I've got a point of 0,4, which was the value up here. If I put that into the function that's given, then that gives me a solution of 12. I've got a point here at 3,2. And if I put that into the function that's given, that evaluates as 9. And then the last point is 4,0. If I put that into the function that was given, that's 4. So that one returns the maximum. Question 11. Given that function, find the 3 points where the curve cuts the x-axis. So for that we need to put the function equal to 0. So for part 1 we have 0 equals x cubed minus 3x squared minus 4x. Every term has an x in, so that makes it quite nice to begin factorising. So we'll take an x out and that will leave us a quadratic of x squared minus 3x minus 4, and I can see that that will factorise into 2 brackets of x plus 1 and x minus 4, which gives me the x values of x is 0 for this one, x is negative 1 for this bracket, x is 4 for that bracket. As for the coordinates, so I need to substitute those x values back into the original function, work out the y values, which give me the coordinates of 0, 0, negative 1, 0, and 4, 0. Of course you don't really need to substitute back in, you know they're all at 0, but it does ask for the 3 points, so we got to quote the full coordinates for that. Sketch the graph. So to sketch the graph, let's position that, set up a couple of axes. Got a y-axis and an x-axis. Just move that a bit. So we need to label the key values. We know we've got solutions at negative 1 and 0 and then at 4. Just go up to 5. Label that as x, label that as y. So the function goes through negative 1, 0 and 4. It's a cubic. So it's this kind of shape. It's difficult to draw on a tablet. Avoid little things like that on your curve where possible. Try and draw it as a single smooth curve. For part B, it's we're given a different function g. Find the remainder when it's divided by x plus 1. So to find the remainder, we evaluate g, and if we want to find the remainder from dividing by x plus 1, we evaluate it with negative 1. So that'll give me minus 1 minus 3 plus 4 plus 12 equals 12. So that's the remainder. That's that part done. Part 2, it asks to show that x minus 2 is a factor. So if that were true, g of 2, change the sign from negative 2 to positive 2. This should be 0. So if we evaluate it with 2, we get 8 minus 12 minus 8 plus 12, and collecting those number terms gives us 0. Therefore x minus 2 is a factor. So that makes sure I've reflected to the examiner that I know that it had to equal 0 from that function to show it was a factor. What's the last part? Solve the equation g of x equals 0. So if we put 0 equal to the function for g, which is x cubed minus 3x squared minus 4x plus 12. So what I need is to reduce it down to a quadratic and factorise that. Now I do know that x minus 2 is a factor, so I can divide x minus 2 into this, and there won't be a remainder. So we begin by saying x into x cubed is x squared. X squared times this is x cubed minus 2x squared. Do the subtraction. The cubic terms disappear. Negative 3 minus negative 2 becomes negative x squared. Bring down the minus 4x. X into negative x squared goes negative x. Multiply through again, so I get minus x squared plus 2x. Whoops. Let's do that again. So x squared plus 2x. Do the subtraction, the x squareds disappear. Negative 4 minus positive 2x is minus 6x. Bring down the plus 12. X into minus 6x is minus 6. Multiply that back through. Minus 6x plus 12, which is what we expect, because when we do this subtraction we get 0, so there's no remainder. Sorry, that wasn't on screen, was it? The last bit. So we had minus x squared plus 2x. We did the subtraction to get minus 6x. X into there goes minus 6. Multiply back through, and so on. So we've got the quadratic here, x squared minus 6x. So if I put that all together, I've got 0 equals the factor we already had, x minus 2. And then I know that the x squared minus 6x minus 6 is going to factorise into a quadratic, which is minus 3 plus 2. So the solutions to g of x are that x equals 2, x equals 3, x equals negative 2. Question 12. Workforce of a large company is made up of males and females in a ratio of 9 to 11. 1/3 of male employees work part-time, 1/2 of female work part-time. 8 employees are chosen at random. So for part 1, the probability they are all males is the probability of picking male is, because it's a ratio of 9 to 11, so convert that to a fraction. 9 over 20, the 20 comes from 11 plus 9. If we're choosing 8, then it will be 9 20ths times 9 20ths, 8 times. There's only one combination or way to arrange that. So we need to calculate that. So 9 20ths to the power of 8. 1.68 times 10 to the negative 3. That would be 0.00168. And I'm going to leave that rounded off, as I've done it there, to 3 significant figures, which it says in the examiner's reports quite often for this qualification that 3 significant figures is a preferred rounding. So we'll use that. For part 2, we need the probability of 5 females so from 8 we're choosing 5. The probability of females is 11 out of 20. We want 5 of those, and then for males they have to make up the rest. There has to be 3. 3 plus 5 has to come to that 8 that was given originally. So to work that out, we'll bring up the calculator, and it's 8 combination 5 times the fraction 11 over 20 to the power of 5 times the fraction 9 over 20, and that's to the power of 3, which is 0.2568. So using the rounding from earlier, we'll round that off to 3 significant figures as 0.257. Okay, so for part 3, at least 2 work part-time. So we need to start by working out how many part-timers there are, because based on a ratio of 9 to 11 male to female, 1/3 of male employees are part-time, work part-time, and half of females are part-time as well. So we need to get some information on that before we can proceed. We knew earlier that 9 plus 11 for the ratio comes up to 20. At this stage though, I can't, while I can do 1/3 of this, I can't do 1/2 of 11. So because it's a ratio, what I'm going to do is double that up. It will mean the same thing and say it's 18 to 22, giving us 40 people, because I can do 1/3 of 18 and I can do 1/2 of 22 and work out how many there are full-timers. Because it's actually full-times I'm going to need in a minute. I'll show you why in a second. So what I need is, if 1/3 are part-time for males, 2/3 work full-time, 2/3 is 12. If half the women are part-time, half of them are full-time, so 1/2 of 22 is 11, which means they're basing it on, you know, a ratio from before, that there are 23 full-timers compared to 14 total, which can be scaled. So because we're going to make a fraction out of that later, the proportion will be correct regardless of what the actual numbers were. Now, to work out the probability of at least to part-timers, that would be a big calculation. But what always happens with the at leasts, if you recognise the exhaustive probabilities have to add up to 1, if I take away the probability that they are all full-time, okay, so that's no part-timers, and then take away from that the probability of 7 full-timers with 1 part-time. When I've calculated that, whatever's left must be at least 2 part-timers. So I've got no part-timers here, 1 part-timer here, take that away, I'm left with at least 2 for everything else. So to put that together, it's 1 minus, now just for completeness, I'm going to show what the combination is here. For all full-time, I'm choosing from 8 people that 8 of them are full-time. The probability of a full-timer is 23 out of 40 now, and that's going to be to the power of 8. Obviously 8C8 reduces to 1, but I'm putting it in there so you can compare it to the formulas that you'll have seen elsewhere. And I want to choose from 8 people to have 7 full-timers. The probability of a full-time person is 23 out of 40. And I'm having 7 of them, and I must put that with 1 person not being full-time, which is 17 over 40, and that will be to the power 1. Okay, so if we calculate these parts, then we've got, I'll put it in anyway, 8 choose 8 times the fraction 23 over 40, and that's the power of 8. So if we round that off, it's 0.0119. And the other part of the calculation, I've got 8 choose 7 times the probability of them being full-time is 23 over 40 to the power of 7, because I'm choosing 7 of them, times the probability of choosing somebody who's a part-timer, that's 17 out of 40, and that's the power 1. So I don't need to put that. That's 0.0706, which I'll round off to 707. And then if I calculate that through, that will give me quite sure what happened there. That will give me 0.917. Question 13, for the pyramid given, we've got various lengths that we know. We have to find the length OM and CM. So to do that, long question. Okay, so for part 1, I've got a triangle to solve to calculate OM. I know this is 12, this is 37, so OM is 37 squared minus 12 squared, and that's square rooted, which is the square root of 1225, which is 35 centimeters. For CM, triangle I'm thinking of here, is this one there, CM. B to C is 20, B to M is 12, so C to M is 20 squared minus 12 squared square rooted, which is the square root of 256, and that's 16 centimetres. That's our part done. So for part 2, we're asked the angle between the line OC and the plane, in which case the triangle I'm thinking of here is CMO. This is 40, this is 16, this is 35, and I want the angle here. So if I use the cosine rule, a squared equals b squared plus c squared minus 2bc cos a, and I've labelled a as theta in this diagram. By doing all the rearranging and substituting in, I'd get a is 35 squared minus b squared, which I'm going to put in as 40 squared, minus c squared, that's 16. Then divide through by the minus 2 times b times c. That equals cos a. So cos a equals negative 631 over negative 1280. Negatives cancel, which gives me 0.49. Do the inverse cosine of that to get the angle, and that will be 60.5 degrees. For part 3, the volume of the pyramid, and we're told the volume of a pyramid is 1/3 of the base area times the height. So we need the height, so we'll imagine another triangle that's in that diagram. We know that angle is 60.5. I want the height. I know that's 40 up to over there. So the sine of 60.5 equals the opposite h over the hypotenuse. Calculating out, h is 34.8 centimetres. So the volume is 1/3 of the area of the base. If I look at the base, I've worked out C to M is 12, and I've got A to B here. So the volume is 1/3 of 24 times 16 over 2. That's the area of the base, times the height that I've just worked out of 34.8. That comes to 2,227.3. Again, sticking with the preferred rounding of the examiners, I'm going to round that off to 3 significant figures. There's no need for a decimal 0.3 on a number that's in the 2000s. So I'm going to round that off to 2,230 centimetres cubed, and I'll put a note to the examiner that that was rounded by me to 3 significant figures. Okay, question 14. Extending the ladder has 2 positions as shown, and we're given information about moving the position of the ladders and so on. Question part 1 says, use Pythagoras' theorem to write down 2 equations in x and y, which is a relatively straightforward thing. We've got a right angle triangle in each one. So if we begin with that, then I can write down from the first one that x squared equals y squared plus 4, x being the hypotenuse. For the other triangle, the hypotenuse is x plus 0.95 squared, and that will equal y plus 1.05 squared. Let's just get rid of that. And plus 2 squared, which is 4. So there's two equations. That's part 1 done. For part 2, show 2.1y equals 1.9x. So what I notice here is that there are no x squareds or y squareds anymore. So however this has been arrived at must be because the x squareds have been eliminated along with the y squared. So if I look at these two equations, I notice that if I multiply this one out, there'll be single x squared, single y squared, which we've got here. So by subtracting one equation from another, they'll hopefully eliminate. So let's get on with multiplying out this x plus 0.95 squared thing. So that would give me x squared plus 0.95x plus 0.95x is 1.9x if I collect those together, and then 0.95 squared will be 0.9025, and that will equal this bracket squared, so that'll give me a y squared plus 1.05y plus 1.05y, which is 2.1y, plus 1.05 squared, which is 1.1025, and there's still the plus 4 on the end. Let's just rewrite that, doesn't look very good. So that should have been 1.1025 plus 4. So I'm going to call this equation 2 and this equation 1, and if I do equation 2 subtract equation 1, so I'm hoping to eliminate some squared terms, then on the left hand side x squared take x squared, cancel, so that leaves 1.9x plus 0.9025, and on the right hand side I'll get y squared take y squared, they eliminate, 2.1y plus 1.1025, but also the plus 4 here and the plus 4 here will cancel, so that leaves me what I've got here. I'll collect the number term over to the left by subtracting it, so that gives me 1.9x minus 0.2 will equal 2.1y, which is what I was asked to show, just the left and right hand sides are on different sides, so I'll leave that as it is, that'll be okay. Question 3, or part 3, using these equations form a quadratic in x and find the values of x and y. So to form a quadratic, I'm going to take the simplest of the two starting equations, x squared equals y squared plus 4, and then what I think I'll do is I'll substitute for y by taking this previous function and rearranging that for y, because all I've got to do is divide by the 2.1, so I'll put that down next to it. So I'm going to take this, divide 1.9x minus 0.2, and I'm dividing that by 2.1. So that's going to get substituted into here, which is going to make a bit of a horrible looking bit of algebra, but we'll see what happens. X squared equals y squared, y has been replaced with this, so 1.9x minus 0.2 all over 2.1, that's all squared, and there's plus 4 on the end. So let's begin multiplying that bracket out, which will give me x squared equals 3.61 x squared, that's your 1.9 x squared. Then I'll have a 0.38 x because of 1.9 times 0.2, and there'll be two of those, so I'll collect those together to save some extra lines of algebra. That'll be 0.76 x. Then I've got negative 0.2 times negative 0.2 becomes plus 0.04. That's all over 2.1, which is squared. That becomes 4.41, and I've still got plus 4 here. I think the next most sensible thing is to multiply through by the 4.41, so that will give me 4.41 x squared equals 3.61 x squared minus 0.76 x plus 0.04 plus 4 times 4.41, which becomes 17.64. If I tidy all of this up by subtracting this x squared term, if I take that away, I get 0.8. Oops. I get 0.8 x squared will equal, there's only one x term, minus 0.76 x, and if I collect the number terms together, 17.68. So it's starting to tidy up a lot now. I'll collect everything over to the left, so I get the standard form for a quadratic. So 0.8x squared, add 0.76 to both sides, 0.76x, so I get plus 0.76x, subtract the number term, that will be equal to 0, and that's a quadratic. So all I've got to do is solve that now. Just bring it back into shot. So to solve that, obviously lots of decimals, we're going to do it with the formula. So x equals minus b minus 0.76 plus or minus the square root of b squared minus 4ac, so a is 0.8, c is negative 17.68. All over 2a, so that's 2 times 0.8. If I push that through the calculator, then I get x is 4.25 and x is negative 5.2, and this solution I'll dismiss, because if you go back to the original diagram, if x is negative 5.2, then negative 5.2 doesn't make any sense for the length of that ladder in either diagram. So we can dismiss that solution of x, just bring it right back. So that means we're focusing on this 4.25. It asked us to solve for x and y. So if I go back to the x squared equals y squared plus 4 and rearrange that for y, I get x squared minus 4 square rooted. Substitute in the 4.25, I get that y is 3.75.